Hi everyone, thanks for joining me on Last Minute Maths. And in this video, we're going to go through the EDEXCEL Maths GCSE higher tier, paper 1, which is a non-calc paper from May 2022. All right, so that's the most recent one at this time. And as always, if you have any questions, anything confuses you about it, please do put it in the comments, any suggestions, etc. Always welcome. All right, we're going to run through this, I hope, quicker than usual. Question number 1, all right, inequality, you can see there, and not to waste any time, it's a straightforward linear inequality, just a 7x minus 27 less than 8. Move the 27 as a plus to the other side, and you get 7x is less than 35. Divide both sides by 7, and you get x is less than 5. All right, that's your answer there. Nice and simple. Okay, number 2. 124 as a product of its prime factors. Well, it's an even number. Okay, so always start with 2. Divide by 2 leaves you with 62. Divide by 2 again, and you're left with 31. Can't go any further than that. So the answer to the question is a product 2 times 2 times 31. You can also write it as 2 squared times 31. That is also acceptable. All right. Number 3, ratios. Okay. And it's sort of like ratios within ratios, this one. Okay, delivery company has a total of 160 cars. So that's the total number. And they are divided into cars and vans in the ratio of 3 to 7, as you can see. All right. So first thing we do, remember that total is 10. So 10 parts, if you like. All right. So I'm going to put it into fractions. So cars to vans, it's 3/10 to 7/10. All right. Okay, going from there. If we then apply the 3/10, for example, times the 160 total, all right, that's same as 3 times 16 and 48. So you can see where I got those numbers from, yeah? Same for the 112, so 7/10 times 160. Okay, so we're not interested in the vans. The question is saying, work out the number of cars that use petrol, all right? And we have to use these bits of data. It says 1/8 of the cars use electricity, 25% of the cars use diesel, so, call that a quarter if you want. And we need to eliminate those two items, and whatever's left over within the cars is going to be petrol, all right? So of the 48 cars, times it by 1/8, that equals 6, all right? And then 25% of the cars, so again, 25% of 48, right, is 12. So a total of 18, okay? So 48 minus 18, you're left with 30 that use petrol. Okay, so that's your straightforward answer there, 30. All right, number 4, standard form. So what we're going to do is take 1.63 times 10 to the minus 3 as an ordinary number. So first we write it as 1.63, as I've done, and we're moving the decimal place, because it's 10 to the minus 3, we're moving it effectively to the left, all right, 3 times, all right? So that leaves us with 0.00163. So that's self-evident. Then the next one, 438,000 in standard form. Well, remember standard form, we always have to have a number between 1, so call it x if you like, greater than or equal to 1, and less than 10, all right? It can be 9.999 whatever, but less than 10. So we want to effectively move the decimal place, right, divided by however many tens we need, and that's actually 5 moves, all right, to make it into 4.38. So therefore, it's 4.38 times 10 to the power 5. Again, that's where the 5 comes from. Again, I hope that's fairly easy to see. Right, next one. Work out 4 times 10 to the power 3 times 6 times 10 to the power minus 5. Now, the important thing is here that we can take the base figures, 4 and the 6, multiply those. So that's where you get the 24, okay? And then do the powers of 10 separately, okay? That is perfectly allowed. And so 10 to the 3 times 10 to the minus 5, okay, is 10 to the minus 2, because if you remember, if we do x to the a times x to the b is x to the power a plus b. So you're adding the powers of 3 plus minus 5 minus 2. Now, remember what I said before. What this gives us, 24 times 10 to the minus 2, but we can't have 24. All right? We have to have something between 1 and 10. So you need to divide that by 10 to make it 2.4. And in order to do that, we're actually reducing the power of the 10 to the minus 2 becomes 10 to the minus 1. All right? Just to show you what that number would have been. That. All right? So if we want to write it as 10, well, so let's, sorry, 2.4, then it needs to just move over once. Okay? Right. Hope I'm not stumbling over my words too much. So 2.4 times 10 to the power minus 1. Number 5. Right. A couple of things about polygons. I just want to illustrate it here. If you pay attention to this bit, each side is pointing in a particular direction, right? Like that. We're having to turn that way to face along the next side. And then we do it again. So if I illustrate along here, we turn that way and then turn again, and then that turns again, etc. Okay. If it's regular, a regular polygon, it means all the sides are same length. And the exterior angles are all the same. All right. Now, what I'm perhaps trying to explain here is that this shape here is 5-sided, so that's a pentagon. All right. That means we are turning 5 times. So if we're starting off facing this way, then we're turning 5 times in order to come back to where we were. So effectively, that's 360 degrees completed in 5 turns. And that's where we get the exterior angle of 72. Right? And that is true for all polygons. So if we do that, all right, that'll be the exterior angle, where n is the number of sides. So just a bit of revision there. Okay. So we know that that angle there, as I've shown, is 72, which means that the interior angle, all right, remember because it's on a straight line, the interior angle is 108, all right, and regular polygon again, so they're all 108. So that's 108 as well, all right. Now, on this side, we have a hexagon, so, sorry, not that one. On this one, and with a hexagon, again, 360 divided by 6, 60, all right? That means all the interior angles are going to be 180 minus 60. So let me just show you that again. We know that that's 60. That's 60, etc. And that means that this angle here is 120. All right, I hope you can see that in all that mess. And I'm going to actually rub out a little bit here. So, following that rule, all those interior angles must be the same. So that's 120. All right. And those of you who know your polygons, you know that hexagons, regular hexagons, can be cut up into 6 equilateral triangles. Okay. Which, without doing all the exterior angle stuff, straight away you know that all the triangles, we draw the triangles themselves, have 60 at each corner, and therefore combined 2 of those will make it 120. All right. Right, enough said on that. So around x, on one side you've got 108, on the other side you've got 120. Okay, so therefore x must be 360 minus the 120 minus the 108, and therefore 132. All right, a little bit of mental maths. I'm not writing down all the workings beyond this. As a maths teacher, we just sort of like tend to run with the numbers. But if you need to in the margins, do extra working out if you want to be sure of what you're doing. Like so, and then do 108 on top of that, and then come to that. So take 30 seconds and do extra working out if you want, right? Do extra or even like over the top working out rather than too little. You don't want to risk losing any marks, all right? But what I've done here is actually perfectly sufficient. So the answer is 132. All right. Number 6, we have a quadratic equation there, x squared minus 3x plus 1. So y equals that, and they want us to fill in the table. So I've done 1, okay? So when x equals minus 1, y equals minus 1 squared, minus 3 times minus 1, plus 1, okay? And minus 1 squared is just 1. Minus 3 times minus 1 plus 3, and then plus 1, all of that put together, 5. Hence the number 5 there. Same process. They don't expect you to write that out for every single one. If you do it once just to demonstrate your method, then, if in case there's any slip up or arithmetic error, they might be more sympathetic and give you at least 1 mark. But hopefully you shouldn't need to rely on that. Okay, so doing the same thing for 2, you get minus 1. For x equals 3, you get 1. X equals 4, you get 5. All right. Okay, so next part is draw the graph. All right, for values of x from minus 1 to minus 4, exactly what's in the table. So as you can see, I've put the points in. All right, so there, and so on. All right. Okay. That's what, 2 marks just for doing that. But make sure your curve goes through the actual points. All right. Use a sharp pencil. And try to be as accurate as you can. Don't miss any of the points. I think out of 6 points, you should cover at least 5. If you slip up on 1, they'll let it go, but no more than that. All right. Part C, using your graph, find estimates, it says, all right, for the solutions of the equation that we've already seen equals 0. So what that means is, effectively, where does the graph cross the x-axis, all right? And I've put those points in there. So it's that one there and that one there, okay? From my graph, I estimate that to be 0.4 and 2.6. Check the squares, count the units properly. Count squares and check scale, right? Must check the scale on each axis. Carefully, all right? 0.4, 2.6. Right, number 7. Two cubes, A and B, and they've given us the dimensions. Now remember, it's cubes, okay? Don't go looking for length, height, width. You only need one side measurement because they're cubes. It's the same all the way around, okay? Cube A has a mass of 81 grams. Cube B has a mass of 128 grams, okay? They want a ratio of the densities of cube A to cube B. So you want integers in the answers, by the way, they've put in. First of all, you need to remember that density is mass over volume, all right? And so the density of A is 81 grams over the volume is going to be 3 cubed, right? 3 times 3 times 3, etc. Okay. On cube B, the measurement was 4, right? So that's 128 grams over 4 cubed. And if you actually work it out, all right, it's 81 over 27 equals 3, and 128 over 4 cubed is 64. It's 2, all right? So the ratio of the densities is 3 to 2. Fairly simple. Number 8. Table shows the amount of snow that fell each day, and it's in centimeters, of course, for 30 days, all right? And double checking, adding up those numbers, it is 30, all right? Now, they want us to work out an estimate, all right, for the mean amount of snow per day, okay? Now, with these ones, first thing you have to do is to work out the midpoint, because this data has been grouped into classes. So, for example, 0 to 10, 10 to 20, etc., without any overlaps. What we need to do is to work out the midpoint for each category. Okay, so the first one, midpoint is 5, second one 15, and so on, 25, 35, and 45. What you then have to do is to multiply the midpoint by its frequency, all right? And do that for each category, each of the classes. So that's what I've done here. 5 times 8 plus 15 times 10, 25 times 7, plus 35 times 2, 45 times 3, as you can see from the table. A quick bit of mental arithmetic, and you end up with 40 plus 150 plus 175 plus 70 plus 135, and the total of all of that is 570. Okay, then the next thing to do is to take that sum, the sum of the midpoints times each frequency, okay, and divide it by the total frequency. So that is the total frequency. Okay, and that's 570 divided by 30, 19. So it's 19 centimeters of snow on average per day. All right. Okay, number 9. Now this one actually looks more complicated than it is. All right. They've given us all the dimensions. So this top one is a cube, and the bottom one is a cuboid, meaning the dimensions are not necessarily all the same. All right. So they're telling us a cube has side length of 4, each edge is 4, and the cuboid dimensions are given 7, 6, and 5. All right. And it says work out the total surface area of the solid. Now, here's the trick. The total surface area would be, let's say under normal circumstances, the two shapes, right, separately done. But because they are in contact, this area is effectively not exposed. It's blocked on both the shapes, okay? Covered on both cuboids, or whatever you want to call them, on both shapes. And that's absolutely critical. I'll come back to that in just a moment. So the area of the cube, to begin with, each face is simply 4 squared. All right, so that's 16. Has a total of 6 faces. So 6 times 16, 96. And then the large cuboid has 3 different size faces, if you like. All right. So one of them is 7 times 6. So that's the base, as it is in the diagram. Then there's 6 times 5, which is a side face. And then there's a front and back face, if you like, 7 times 5. Okay. So hopefully you can see where all those numbers came from. And they total, one of each put together is 107. Okay. And we know that there's 2 of each side of the face. So it's 214 is the total surface area of the cuboid. Now remember what I said about that area that's covered by the cube. Effectively, that area is covered on both shapes. Right? That's removed from both shapes, right? And that area, remember, is 16 square centimeters. So I've put it in as if I were to answer this question myself. Join between 2 shapes covers 16 cubic centimeters from each of the shapes. So 2 times 16 equals 32. So the total separate areas would be 96 plus 214. That's 310. Minus the 32. So there's 16 that's covered on the cube and 16 that's covered on the cuboid. So you can actually reduce the exposed surface area by 32. All right. And so the answer comes out to be 278. There we go. All right. So sometimes observing the question, looking at the diagram, etc., using it wisely can save you time and save you having to do some extra working out. Okay, number 10. Table shows some information about the profit made each day at a cricket club on 100 separate days. All right. And they've given you a profit amount and then the frequency for each sort of category or class or profit, a particular band. And as in some of my previous videos, it's same old thing again, cumulative frequency. All right. And all that means is you are taking a frequency up to and including whatever the class you're talking about. So let me just explain what that means. So between 0 and 50, we know it's 10, so that's fine. But between 0 and 100, we have to take the 0 and the 50, and we have to take the 50 to 100. All right, so you're adding that on. So that's 10 plus 15. And then the next one is 0 to 150. So cumulative, meaning everything up to and including or just below 150 because of the less than sign. And that basically is your 10 plus 15 plus 25 again. So another 25 added on to that, etc. And you sort of work your way down the table. And just looking at it, there's a little quirk in these numbers, and I'm sure they've done it deliberately. You've got a very small increase between 80 and 85 there, so between 200 and 250, and then a larger increase from 250 to 300. Right? That's unusual in the kind of questions that they usually present. And some people might have thought, that's confusing, or it might have thrown them off. Now, what they're asking to do next is on the grid, draw a cumulative frequency graph for this information. Now, this is why I mentioned that strange sort of set of numbers. You normally expect a cumulative graph to be of a shape like this. Like that, all right? This one sort of does that, but then it sort of goes back up again like that, all right? Don't let that put you off. It has no bearing on the actual question or the answers. Follow what the numbers are in the question, okay? And go through the normal way of drawing a graph, trying to catch as many points to a smooth curve, or as smooth as you can, catching as many of the points as possible. And that's fine, because that is what data has been given, all right? So that's what your cumulative graph would look like. I have then in the latter part of the question, I've filled in these lines, and I'll explain where all that's come from. So having done the graph, They're saying use your graph to find an estimate for the number of days. Again, it's an estimate. Number of days on which the profit was less than 125. So there we are, all right, 125 or less. So I want everything on that side there. So effectively, I want to go up, draw the line going up from 125, see where it hits the graph that you have on your piece of paper, and read off the frequency, okay? And I got the frequency to be 39. And so the 39 days where the profit was less than 125. Okay, and then it says, use your graph to find an estimate for the interquartile range. The interquartile range, abbreviated there, IQR, equals the value, right, whatever the profit value would be, for the upper quartile minus the profit value for the lower quartile. Now, the upper quartile, just as a bit of revision, is 3/4 of the frequency, and the lower quartile is 1/4 of the frequency. All right, so in this case, because we know we have a total of 100, your upper quartile is going to be the profit value at 75, and the lower quartile profit value of 25, okay? I.e. where the frequency is 25, read off the profit value for that. So that's what I've done on the graph. So let's take the upper quartile, all right? I've taken 75 here, or as best as I could estimate, and gone across to the graph, see where it intersects, read downwards, and it comes to be, let's say, 185, okay? Again, like I said previously, read the scale and count the squares carefully, all right? So you get 125 for the upper quartile value. And doing exactly the same thing for 25, so that's 25 there. Reading across, hitting the graph there, oops, and reading down, perhaps not to be too pedantic, but it came to what I thought was 87.5, okay? That's my lower quartile value of profit. And so the interquartile range, after I've taken those, is the 185 minus the 87.5, and I've got 97.5, okay? Now, if I remember from last year, their values were actually lower than this, all right? But what they do is that for this type of question, if you've read it off your graph and you've shown the workings on the graph, then as long as the graph itself is not wildly wrong, they allow whatever your graph shows, okay? It doesn't have to be within their particular range, as long as it is relatively accurate on your own graph. Okay, so it's worth spending a few extra seconds on the graph to make sure it's quite correct. Right, number 11, okay? Cormac has some sweets in a bag, all right, and they are lime, strawberry, or orange flavored, okay? And they've given the ratio of the sweets, 9 to 4 to X in that order, so lime, strawberry, orange. And then Cormac is going to take, at random, a sweet from the bag, okay? The probability that he takes a lime flavored one is 3/7. Now, we can work in ratios because it doesn't matter what the actual numbers are, all right? So we know that lime represents 9 out of the total, so 9 parts out of the total, however many parts there are, and the total is 13 plus X, so that's 9 plus 4 plus X, all right? So 9 out of the 13 plus X has an actual value, the probability value is 3/7, okay? If we now cross multiply and get rid of the denominators, 7 times 9, 63, and on the other side we've got 3 times 13 plus X, hence 39 plus 3X. Move the 39 to the other side, 24, so 63 minus 39, 24 equals 3X, and I've just flipped it around for convenience, X equals 8, all right? Okay, number 12, all right? recurring fractions. Now with this one, always start by labeling the original fraction, writing it out a few repeats if you like, and call that x. All right, so that's x. And I've just put in 0.1171717. This is something important to iterate. If I had this, for example, then what that means is the 0.2 is as it is. It's the 3 and the 4 that keep repeating. So that will actually be 2, 3, 4, 3, 4, 3, 4, etc. Okay, so it's only the 3 and the 4 that repeat, for example. So in this one, it's the second 1 and the 7 that keep repeating. Okay, now what we want to do, we can see that the 1 and the 7 are the repeating units. So if we say 10x, then that is 1.171717. And then the next bit where it was going to repeat is 1000x. So that gives us 117.171717, etc. The object is line up the repeating units, or repeating numbers if you like, repeating. Okay, so you need to work out what powers you're going to multiply by 10, 100 or 1000 in order to line up those repeating digits. So in this case, it's 10x and 1000x. So if we say 1000x minus 10x, that's 117.1717 minus 1.1717, etc. Right? That's what we meant about lining it up. And if you minus the smaller one, then you end up with a round figure, an integer. Okay, 116. So that's where this thing comes from. And that gives us 990x equals 116. Again, I've just divided across 116 over 990. And you can reduce that down to 58 over 495. All right, so there's your answer there. Right, number 13. Okay. This question is so much simpler than it looks, and yet it's been presented in a way that caused a lot of students to be confused and not really know how to tackle it initially. All right. What they're saying is show that the areas follow this particular rule. So you've got these semicircles, A, B, and C, right? In whatever order. And they're saying that area of region A, okay? All it means is the semicircle A, area of semicircle A equals the sum of the semicircle B and semicircle C. That's all it is, okay? All right. Now, the important thing to note is that they've been put together with a right angle triangle. And straight away, you should think Pythagoras. All right. So just for ease of doing this, to prove a point, if we were to say that semicircle A has radius A, then the diameter there is 2A, all right? And similarly for B, the diameter, i.e. the length of that side of the triangle is 2B, and C, 2C, all right? And using Pythagoras, we can state that 2B all squared plus 2C all squared equals 2A all squared, which leads to 4B squared plus 4C squared equals 4A squared. Get rid of all the 4's, and you're left with our good old friendly Pythagoras theorem, all right? B squared plus C squared equals A squared. Okay, next, applying a straightforward little bit of circle knowledge, right? Area of a circle, remember, is pi r squared, and the area of a semicircle is obviously going to be half times that, all right? So over 2, okay? So for A, right, the area or region A as they call it in the question is half times what would be the area of the full circle, which is pi a squared. Remember, we defined radius as a, and so on. So the same thing for semicircle B and for semicircle C, all right? So half pi b squared, half, oops, I've made an error there. Apologies before everybody puts it in the comments. It's half pi c squared, all right? So what we need to then do is say, okay, if we take area B plus area C, so half pi b squared plus half pi c squared, we get an expression, factor out the half pi, and you get half pi times brackets b squared plus c squared, all right? And from the rule above, Pythagoras, we know that b squared plus c squared equals a squared. Therefore, we get the area of B plus the area of C equals the area of A, all right? And that effectively is the proof. It really is as simple as that. Okay, number 14. Speed time graph, okay? And it says work out an estimate of the gradient of the graph at t equals 2. So at that point there, and it's effectively there, all right? The way to work out estimates of a gradient on a graph, all right, is to draw a tangent. And sitting in an exam, you've got to just do it by eye, put your ruler on there and try and estimate where it actually seems, fairly reasonable. And the way to do it is to put your ruler on the point, as I've shown here, okay? And then let's say, I don't know, a centimeter either side of it. Try and make sure that the distances you're looking at here are about the same, right? That will roughly give you a tangent that's fairly accurate. It'll never be perfect, but it'll be accurate enough for exam purposes. So once you've got the tangent drawn out, extend it, right, until you get to some sensible points. Like try and pick some, let me just explain over here, sort of like a point at a corner of a couple of squares, right, to another corner where you can actually count whole numbers maybe, or at least one decimal place, all right? Don't go picking sort of middle of a square somewhere, like that, and I don't know, something stupid like this. Yeah, don't do that. Extend it as long as you have to. The longer the line is, the better, the less error that you're going to have, all right? So try and get a nice long line, a big triangle. In this case, I've taken it to two sort of corners that I liked. And this top one, I read it being across there, 4.8, across here, 1.6. So those are the two vertical values, right? Vertical axes. So in other words, speed. And horizontally along the time axis, I read that as being roughly, oops, what have we done? I think I might have made a mistake here. Yeah, I should have written 0. Yep. The numbers were right, as in the calculation was right. I just wrote 1 instead of 0 by accident. So again, don't go correcting me. You can see what I've done. And if it's confused you in any way, please do ask me in the comments. So anyway, that's 0.8, and this one is 4. All right, so what we effectively have in the gradient, you want the vertical difference over the horizontal difference. Under normal circumstances in a graph, it's like the y difference over the x difference, etc. So in this case, I've got 4.8 minus 1.6, 3.2, and the 4 minus 0.8, yeah, which is what I meant to write, and that comes out to be 3.2 as well, all right? So on my particular graph, my estimate, it gives me a gradient of 1. All right. And let me just see if they've given the units. They haven't even bothered giving units here. Okay. But anyway, I get a gradient of 1. All right. As always with these questions, they'll give you a range of values that's acceptable. And, you know, it's 1 mark. Sorry, 1 mark for that actual gradient drawing thing. So, you know, make it as accurate as you can, but at the same time, don't sort of spend several minutes doing that. Okay, so that bit's done. And the last bit of that question, what does the area under the graph represent? Area under a speed time graph is always the distance traveled. All right, nice and simple. Okay, number 15. What have we got here? 3 points, all right? A, B, and AC. So A, B, and C are points. So effectively what we're saying is, for example, you've got that, and C is along that same line, all right? And you have to prove it, given that these are the 2 points. So first we're given AB, and then we're given AC, all right? And prove that all 3 are on the same line. So they're colinear is what effectively they're asking for those of you who like the technical terms. Right, so AC, right, we are told is 15A plus 20B, and that has a common factor of 5, so you take the 5 out, so it's 5 times, brackets, 3A plus 4B, which is the same as AB, so 5 times AB. So therefore, AC is a multiple of AB, and both start at the same point. So you're starting at the same point, going in the same direction. One is going 5 times further than the other one. Okay, so that's enough to prove that they are on a straight line. You need to have this statement. Okay, need a proof statement, if you like, in this type of question. It's not a show that. Show that, if you just write the equation, you're fine. But if it's a proof, you need to actually say, therefore, this logic applies. All right, so make sure you get that in. Okay, then they've got another one. This one is actually a little confusing. D, E, and F are 3 points on a straight line. So they're telling you it's on a straight line. Okay, so saying D to E is 3E plus 6F. The letters don't really matter. They're just like different vectors, whatever, like X and Y. And then E to F is minus 10.5E minus 21F. Okay, and they want us to take a look at the ratio of the length of DF to the length of DE. All right. The way we find DF, right, which we don't have information for up there, is basically you're adding DE plus EF. All right. So take each element, the 3E plus, again, I must have done this paper when I was tired or something. So 3E plus, no. I know what I've done. Yep, I'm not looking. 3E minus 10.5E, all right? I was getting ahead of myself there. And that gives you minus 7.5E. And on the other side, you've got 6F minus 21F. So you basically combine the E's and combine the F's, all right? 6F minus 21F is minus 15F. All right, so that gives you the actual sort of vector for DF. All right. Now, if you compare the, let's say the first bit for the E, in DF, you've got minus 7.5. In DE, you've got 3. So the multiple is minus 2.5. Okay. Double checking it with the F elements of the 2 vectors. Then you've got minus 15 divided by 6. Again, it's minus 2.5, just to double check. So the magnitude, the actual relative size, is 2.5 times. You can ignore the negative because you don't, in ratios, you don't have negative distances. All right, the length cannot be negative. So take positive only. Length is positive. All right, so it's just the length, it doesn't matter what direction. So the plus minus doesn't matter. So effectively, DF to DE, the ratio is 2.5 to 1. And the best thing to do is multiply it up and take it 5 to 2. All right, so there we go. All right. Number 16. And this, I think, is possibly the second most complicated question on the whole paper. And you need to think through it very carefully. All right. So a first aid test has two parts. All right. Theory, practical, it says. The probability of passing the theory is 0.5. Now, here's the really important bit. If passing is the probability of passing is 0.5, then probability of failing equals 1 minus 0.75 equals 0.25. All right? That is critical. Must use that information, must spot it. And then it says the probability of passing only one of the two parts is 0.36. All right? And the two events are independent. So it doesn't matter whether you pass something, it doesn't affect your next test. They're completely independent of each other. Okay. Now, if we are passing only one of the two, then we have to look at the two scenarios. First one is where we pass the theory and then fail the practical. All right, so that's the theory. And the second part is the practical. So passing the theory and failing the practical is, if we call it P for fail there. And the other option, if you like, is where you fail the theory and pass the practical. All right, let's call that Q. Okay, so we know the numbers. There's 0.75 P for that and 0.25 Q. All right, so I've used P and Q for the practical outcomes. So we know that those two, right, because it's either this or that, right, you have to add them. So that means add. So 0.75p plus 0.25q equals 0.36. All right. Okay. So that's the important statement that you need to construct before you can actually do the question. Okay. The next bit is, remember that failing the practical and passing the practical, the two probabilities must add up to 1. Okay. So therefore, P is 1 minus Q. In other words, failing the practical must be 1 minus passing it. All right. And so what we're going to do is replace the P in our original equation with 1 minus Q. So what we've stated there is going to go in there. So 0.75 times where the P was is now 1 minus Q plus 0.25Q equals 0.36. All right, so that statement there. Expand the brackets, 0.75 minus 0.75Q plus 0.25Q equals 0.36. Move things around a little. Now, I've sort of jumped ahead a little here. See that? So you've got 0.25Q minus 0.75Q. So that actually comes to minus 0.5Q on this side. Goes across to the other side as a plus 0.5Q. All right, so that's where I got the 0.5Q there. So 0.75 minus 0.36. Just double check the mental maths. Yeah, 0.39 equals 0.5Q. Again, just swap it around, etc. Whatever makes you happy, whichever order you want to do it in. And it's 0.39 divided by 0.5, and that comes to be 0.78. Remember, I defined Q as passing the practical. All right. There we go. All right. And there's the answer, 0.78. Right, number 17. Okay, proportionality. And again, with all of these things, you'll find that a lot of these, I've got other videos on there if you need to take a closer look at proportions or ratios or quadratics, whatever it might be. There are quite a few other videos on the channel. Do check them out if you need to. All right, when something is directly proportional, all right, then this is what we mean. Okay, and it says to the square root of t. So y is proportional, there's your proportional sign, to square root of t. You can replace that with an equals k times square root of t, all right? And so y equals k root t, and then it gives you a couple of bits of data. Y equals 15 when t equals 9. So substitute those in. 15 equals k times square root of 9, and square root of 9 we know is 3. So 15 divided by 3 must be k, all right? So k equals 5. That gives us an equation for y in terms of t. So y equals 5 times root t, all right? So park that on one side for a moment. Next thing we have is t is inversely proportional, okay? And this is one that throws a lot of people, okay? Inversely proportional means like 1 over, right? So it goes in a denominator instead of just straight across. So t is inversely proportional to 1 over a cube of x, so x to the power 3. And what I've done, instead of using k, which might confuse some people, I've used m, right, as my constant there. All right, so I've said t equals m over x cubed, all right? And you go through the same process again. They've given you some data there. T equals 8 when x equals 2. So 8 equals m over 2 cubed. And 2 cubed, remember, is 8. So m must equal 8 times 8, so 64. So t equals 64 over x cubed. All right, so that's your equation in t. Now, the question is actually saying, find an equation for y in terms of x. All right, so we want to eliminate the t between the two equations. So substitute, okay, because we know y equals 5 root t, okay? So replace the t in the original equation, the y equation, with the 64 over x cubed, okay? And that gives us 5 times square root of 64 on top, which is 8, and the square root of x cubed in the denominator underneath, all right? And so that's just 5 times 8 over square root of x cubed, 40 over square root of x cubed, all right? So that's what you can do there. You could, if you wanted to really sort of labor the point, do powers. You could even do this. So x, so that actually can be written as x to the power 3 over 2, all right? But I think leave it visually as 40 over square root of x cubed is probably much simpler, all right? This one is not actually a difficult question. It just looks a little messy. Just patiently go through it. It's just visual algebra, really, nothing more than that. Okay, first thing is convert the mixed numbers into improper fractions. So the first one, 5 and 4/9. 9 5s are 45, plus 4, in case you've forgotten how to do this, and you get 49 over 9, all right? So same process for the 4 and 2/3. Okay, so we have 49 over 9 to the power minus 1/2. Remember, anything to the power 1/2 is a square root, all right? Times 14 over 3. And then underneath it, if you have 2 to the power minus 3, the minus means it's flipped across, so 2 to the minus 1 is that, all right, etc. So that's what we're using. I have a video there, law of indices. So if you're not sure about these, do take a moment to, well, sometime later on, check that video out, and all of this is explained in that, all right, in quite some detail. Right, so we have the whole thing rewritten with a sort of like the numbers actually worked out properly. So effectively, you've got the 49 over 9 to the power minus half. Get rid of the minus by flipping it upside down. So you get 9 over 49 to the power half, okay, times 14 over 3. Underneath it, divide by 1/8. And that works out to be, if you take the square root of 9 over 49, that's 3/7, and times 14 over 3. So the 3's cancel, 14 over 7 is 2. So all of that is 2 over 1/8, okay? And so 2 divided by 1/8 is the same as 2 times, flip the 1/8 upside down, becomes 8, and that's 16. So it's not actually as bad as you think, but you need to know your index laws, all right? Number 19, okay, algebraic fractions. And what we do here is exactly as you would do with any other fractions. You sort of find a common denominator and combine the two fractions, okay? So the first one, I'm multiplying top and bottom by x minus 1. So effectively it's cross-multiplying, if you like. And I'm multiplying the second one, top and bottom, by 2x minus 1, as you can see, all right? Haven't touched the right-hand side yet. All right, so the common denominator is going to be 2x minus 1 times x minus 1, all right? So the top bit, expand the brackets out, so it's just x minus 1, plus 3 times 2x, 6x, and 3 times minus 1, minus 3, all right? And that, as you can see, will come out to be 7x minus 4, all right? And then we multiply the denominators across to the other side, and in this particular case, it's just a 1. So there isn't any actual expansion to just put the two brackets onto the right-hand side, multiply across. Then expand them. So you've got 7x minus 4. And with this one here, just to see where the numbers came from, 2x times x, 2x times minus 1, and then minus 1 times x, minus 1 times minus 1. All right? That's where 2x squared minus 3x plus 1 comes from. Move everything onto one side, all right? I'm keeping the x squared positive, so I've moved everything to the right-hand side. And you end up with 2x squared minus 10x plus 5. And they've said in the question, just look at that again, they wanted in the surd form. Now, believe it or not, just a couple of days ago, I did a video on the quadratic formula, coincidentally, explaining exactly the difference between putting something in surd form or exact form, or if it's calculator paper, then they might ask you for answers to 2 decimal places or something like that. This is non-calc paper, so they're asking you to leave it in surd form, and the easiest way to do that is use the quadratic formula. So there's a quadratic formula video if you want to check it out. It's only a few minutes, something very simple. So put those numbers in there. Remember that quadratic is ax squared plus bx plus c. All right, so those are the numbers. Okay, so there's the formula for you. I've written it out. You should really know it. So b, in this case, all right, well, let's go through it. A equals 2, b equals minus 10, and c equals 5. So minus b means it's minus minus 10. Okay, so watch out for that. All right, so that's plus 10. Plus minus square root of the whole of b squared, which is 10, and then 4ac. A times c, as you can see, is 2 times 5, 10, times 4, 40. All right, so that effectively gives us root 60. And then just to put it on the side, like surds, root 60 can be split into root 4 times 15, root 4 times root 15, and therefore that's 2 times root 15. So put that back into the formula. 10 plus minus 2 root 15, all divided by 4, all right, which is the 2a bit. And cancel 2 top and bottom, okay? And you're left with 5 plus minus 15 over 2. And that is actually the answer. I suppose I should write it in, shouldn't I? Okay, there you go. Right, number 20. Bit of geometry here, all right? The center of a circle is a point with coordinates -1, 3, all right? And point A with coordinates 6, 8 lies on the circle. And it says find an equation of the tangent to the circle at that point A, all right? Always sketch to the best of your ability. Just do a rough sketch, so you can visualize what's going on. It's so much easier to see the question than to read it, okay? So please, wherever possible, any geometry question, just do a rough sketch. It doesn't have to be perfect. I mean, look what I've done here. It's just a pair of axes, roughly estimating -1, 3. On the other side, 6, 8. It doesn't have to be really to scale or anything like that, but a sensible little sketch, all right? Okay, so if C is the center, all right, and A is the point on the circle, so that means on the circumference, then from C to A must be a radius, okay? And then a tangent, right, at that point A must be perpendicular to the radius, all right? So radius and tangent at A are perpendicular. That is absolutely critical information, right? Okay, so first of all, we want to work out the gradient of the radius. Remember, the gradient is y2 minus y1 over x2 minus x1 for 2 given points, all right? So some of you have learned it as rise over run, etc. Okay, so whatever makes you happy, whichever way you want to do it, as long as you don't get them the wrong way around. Okay, so the gradient of the radius itself is the y values, all right? The difference between the y values, so 8 minus 3 divided by 6 minus -1, yeah? Watch out for the sign. Watch the sign. Okay, don't make small silly mistakes like this. 8 minus 3, 5, and 6 minus -1 is 7. So the gradient of the radius is 5/7. And so the gradient of the tangent is the negative reciprocal, all right? All that means, and I think I've done it so many times in my previous videos, simple rule, it's m, i.e. a gradient, all right, equals 1 minus 1 over m2. All right, that's the official thing that's in your textbooks, okay? What you actually wanted to do is this. Flip upside down and reverse the sign. So if it started off positive, it'll become negative. If it was negative, it'll become positive, right? And flip the number upside down, whatever it is. So for example, if you have 3, the flip of 3 is 1 over 3, okay? If you flip quarter upside down, you get 4, and so on. So if you get 2/3, that'll flip to being 3 over 2, etc. And then you reverse the sign, whatever the sign was to start with. In this case, we had a positive, so that's actually a positive. And so we flip it upside down, you get 7 over 5, and you reverse the sign, so it's negative. Okay. So therefore, the equation of the tangent starts off life looking like this. Y equals -7/5 x plus c. All right. We don't yet know what the c is. Okay, to find C, and I'll write it here. Again, I've done this in previous videos. Substitute in coordinates of any point the line goes through. There we go. All right. And so in this case, we know it goes through 6, 8. So put in y equals 8, x equals 6 into our initial equation and solve for C. All right. Now, I've just sort of like sped the thing up a little bit. 6 times minus 7 over 5 is minus 42 over 5. So what I've done is turn the 8 into something over 5. So effectively that's multiplying the 8 by 5 is 40, divided by 5, etc. So to solve for C, take the minus 42 over 5, bring it round to the left-hand side, and you get C equals 82 over 5. Therefore, putting it back in, the whole equation is y equals minus 7/5 x plus 82 over 5. Multiply everything by 5, and you get 5y equals minus 7x plus 82. And put everything to the left-hand side, you get 7x plus 5y minus 82 equals 0. So that's the format that they're looking for. All right. Okay, this is the question that had everybody up in arms last year. And I think the very evening of that exam, there were dozens of YouTube videos on this particular question, right, and the solution and so on and so forth. And I stayed well away from it. There's already too many things out there. But it's got to be done for part of this paper. And there's a couple of aspects of this which I think those of you who are revising for your paper 1, please pay attention to the probability questions and this particular question. There are some aspects of it that just are necessary to know, and I'll explain why in a moment. Okay, first thing, read the question carefully, all right? Read and observe carefully. Okay, all right, I can't emphasize that enough. And right, they've said 3 circles, radius 4, all right? The centers of the circles are A, B, and C such that ABC is a straight line, and A to B, B to C equals 4. So this is 4, that's 4. So effectively, these are all radii. So each one of those lines is a radius. So you've got from A to the edge, right? That must be a radius. And then from B to that same point, i.e. the edge, right? Both of those, again, that's a radius. Each of those is a radius, all right? And so on. So that effectively tells us that that is an equilateral triangle, all right? So that thing there is an equilateral triangle. All right, so look at what the question's asking for. Work out the total area of the 2 shaded regions, okay? And give your answer in terms of pi. All right, so the 2 shaded regions, right, effectively is a circle minus, okay, the white area, or the unshaded region, if you like, yeah? All right, as opposed to the gray. So the gray bit is what's left over when you take those 2 areas away from the circle, the full circle. Okay, now you can see that if I take a look at this sort of like top bit here, what you have is an equilateral triangle, right, which forms part of a sector of a circle. So if I draw that like that, I mean it's a little steeper, and there, okay? And so effectively, if I look at it that way, what I need to find, i.e. this unshaded area here, I need to find 4 equilateral triangles and 8 segments. That's the value of that area. Okay, so if I find the area of one of those triangles and the area of a segment, then I take 4 of one, 8 of the other, and add that all up, whatever it is, take it away from the full circle, and it gives me the shaded regions. All right, so that basically is the method in a nutshell. So first of all, in the triangle, all right, we know it's an equilateral, so 60 degrees and all the sides are 4. I'm going to use my area sine rule, all right, half AB sine C, okay, and it's half times 4 times 4 times sine 60. Now this is the bit I wanted everybody to pay attention to, those of you still watching, all right. You must know your trig values, okay, it's essential, and if necessary I'll put it into another video later, but you must know this. Sine 60 equals root 3 over 2, all right. So if you haven't learned your principal values, so 0, 30, 45, 60, and 90, please learn them before your paper 1. Okay, you won't have a calculator, and in the last 2 or 3 years, it's come up over and over again where they've needed you to know the trigonometric ratios for those principal angles, sine, cos, and tan. All right, so watch out for that. Okay, so very simply here, half times 4 times 4, 8 times root 3 over 2, and that's 4 root 3. Okay, so that's the area of one triangle. Okay, I better put that in. Area of one triangle. Okay, and then the sector that I was talking about, all right? The reason I need the sector is that in order to find the area of a segment, okay, I need to find the area of a sector, take away the triangle, leaves me the segment, okay? So the area of a sector is like, it's a pie, you know, a slice of a pie, a cake, a pizza, whatever you want to call it. And we know that the angle at the center is 60. So it's going to be 60 over 360, which would be the full circle, times the area of the full circle. So it's a fraction of the full circle given by the angle over 360. So that's basically 1/6 times 16 pi, all right? So you can see that there, and that's 8 pi over 3. All right, so that's my sector. So next step, the segment, all right? Let me just remind you what I mean by the segment. That is the segment. Okay? All right. So the segment is a sector minus a triangle that I've already found. So the sector we know is 8 pi over 3 minus a triangle 4 root 3. Okay? So there's my segment. And I'm going to leave it like that because you can't really simplify it any further. The unshaded area, therefore, is, remember what I said, 4 triangles, all right, and 8 segments, okay? Expanding all that out, okay, I get 16 root 3 plus 64 pi over 3 minus 32 root 3. Tidy that up, and you end up with 64 pi over 3 minus 16 root 3. And that then allows us to get the final answer, which is over here, okay, after all of that. And so the shaded area, all right, is the full circle, okay, remember what I said right at the top, full circle, that's 16 pi, minus the unshaded area, which is your 64 pi over 3 minus 16 root 3. And again, if you just expand the bracket out, 64 pi minus, that is, so 16 minus 64 over 3 actually comes to minus 16 pi over 3 plus, and this is a plus because it's minus, so watch out, minus, minus, all right, plus 16 root 3. So your answer comes out to be 16 root 3 minus 16 pi over 3. Okay, there is the answer. That's what made so many people cry last year. All right, it's not as bad as people thought, but it just takes a bit of patience. And I've tried to label it like step 1, step 2, step 3, step 4. Hopefully, you can follow that clearly. And again, sketch, draw out what you're doing. And that hopefully will help you understand exactly what you need to find and how to find it. Okay, and do learn the trigonometric values. Right, that's everything for that paper. Hope it's been useful, and if you have any comments, questions, etc., as I always say, please leave it in the comments. They are very welcome. And if you perhaps have found this useful, please do subscribe and click a like somewhere or something, and watch out for other videos that I'm doing to help with the revision for the GCSEs. And if you have any particular topics or questions that you'd like covered, then feel free, get in touch, let me know. And as I've done for some of my other students and some other viewers who are not my students, have asked me for particular topics, and I've done those. So very happy to do that if I can. And finally, wish you best of luck with your exams and your revision, and hopefully fortune will smile on you on the day. All right. Good luck. Thanks for watching.